Good morning students, myself Venkatesh, Department of CSE. Today we are going to talk about scheduling algorithm topic. Okay, this scheduling algorithms comes under CPU scheduling concept in unit 2. Okay, so what are the various scheduling algorithms, what are the working principle of various scheduling algorithms, all those things we are going to discuss in this class. Okay, so before going to see various scheduling algorithms, okay, let us see a brief look about a process states. Okay, if you see the what are the various states of a process means, if we have new is one state, okay, again ready and running, at the same time waiting is one state, and finally termination is one state. Okay, whenever a process is created, those process will be in the new state. Okay, after creating the process will come to the ready state. Okay, after ready state the process will move to the running state for execution. It means the process is in running state means the process is executed by the processor. Okay, so at the same time, if the process is executed by the processor, after completion of the process, okay, it will terminate the that process. Okay, otherwise if a process is running state, if it needs any resources like IO devices, it will come to the waiting state. From waiting state to the after completion of the waiting state, again it will go to the ready state. From ready state to the running state, and from running state to the terminated state. Okay, this is the life cycle of a process. Okay, for example, if a process is executing in running state, that means a process is executed by the processor, there is one more process with highest priority came to the ready state, then what will happen? The process which is executed by the processor in running state, that will move to the ready state. That way we can call it as an interrupt. Okay, why? Because we have to give chance to the highest priority process. Okay, so these are the various states of a process, how a process will switches from ready to running, and running to waiting, again waiting to ready state. Okay, so all these are the different states of a process. Okay, so if you have brief idea about the states, then it is easy to understand the scheduling algorithms. Okay, well, let us see what is the CPU scheduling. See, generally the major agenda of the CPU scheduling is, here CPU means the processor. Okay, whenever we take this CPU scheduling concept, always the processor is busy with executing some of the processes. Okay, that means the processor should not be in the idle state. Okay, see, for example, there is one process. Okay, that process came to the ready state. From ready state to the running state. Okay, running state in the sense the process is executed by the processor. Okay, if that process needs some of the IO device, then what will happen? That process will move to the waiting state. In this meanwhile, the processor is in idle state. Okay, what this CPU scheduling is saying, it should not be like that. Okay, the process is, whenever the process is running in the running state, okay, that process needs IO devices, it moves from running state to the waiting state. Automatically the operating system give one more process to the processor. Why? Because the processor is in ideal state. Okay, the main goal of CPU scheduling is the processor is always busy with executing some of the processes. Okay, if it is a case only, then only we are going to get the 100% achievement of the processor. That means in order to get the 100% of utilization of this processor, we are going to execute any process at any point of time by the processor. Okay, here CPU scheduling is a process which allows one process to use the CPU while the execution of another process is on hold. It means if there is one more process, it is on waiting state, so automatically what will happen? The CPU is idle state. Okay, in order to avoid that idle state, there is one more process will give to the processor. Okay, so here what will happen is while keeping the CPU always busy, we are going to make the system very efficient and fast and fair. Okay, whenever CPU becomes idle, automatically what will happen? The operating system will move process which are in ready state to the running state. Okay, so this is the CPU scheduling. Okay, whereas coming to types of CPU scheduling, generally here types in the sense, if you take the states of a processes, okay, there are majorly switchings happen. That means from running state to the waiting state, and running state to the ready state, at the same time waiting state to the ready state, okay, as we know all these states, okay. But here what will happen is, there are majorly if you take the CPU scheduling concept, there are majorly four circumstances will happen. The first one is when a process switches from running state to the waiting state, okay. When the process switches from running state to the waiting state, if it needs any IO device, then automatically what will happen, the process which is in running state, process will move from running state to the waiting state. This is one case, okay. Again, second case is what will happen, the process which switches from running state to the ready state. When it switches from ready state to the running state to the ready state means, just now we have discussed, right now, no. So whenever there is interrupt occur, what is meant by interrupt? For example, a process which is executed by the processor, it means it is in running state, okay. Whenever the process is in running state, there is one more process with the highest priority came into the ready state. What will happen? So definitely we have to give chance to the ready state. So here what will happen is, the process which is in running state, that will move to the ready state. That means it will switches from running state to the ready state. Why? Because there is an interrupt here. Interrupt in the sense, a process with highest priority. This is one case, okay. Whereas next third one is, when a process switches from waiting state to the ready state. When it will happen? Generally when the process come to the waiting state, if a process is executing in running state, if it needs IO devices, definitely it will go to the waiting state, okay. After receiving the IO devices, what it will happen? Again it will go to the ready state. Why? Because that process will not complete its execution. So what will happen? Why it will came to the waiting state? For accessing the IO device. After accessing the IO device, completion of the IO device, access of IO device, what will happen? It will move to the again ready state, okay. From again ready state to the running state for execution, okay. So this is the third one, switching from waiting state to the ready state. Generally, fourth one is process terminate. When process terminates, for example, there is one process. That process they don't need any IO device. What will happen? From new to ready to running, from running to terminates. This is fourth one. There is no interruption, okay. Here, where this scheduling concept is concerned, there is two things. First one is, there is a interruption or without interruption, okay. Interruption or without interruption. Without interruption means from ready to new to running, ready to running to exit, okay. That means terminate. That means there is no interruption, okay. That we can call it as a non-preemptive, okay. Non-preemptive means there is no interruption, okay. Whereas preemptive means, here preemptive means generally two things, okay. Ready to running, okay. From running to waiting, there is an interrupt. Whenever interrupt occurs only, it will move from running to waiting state. Or there is one more chance, from running to ready. When it will occurs, whenever there is interrupt occurs, then automatically from running to ready, okay. So then we can call it as a interruption, okay. That means there is complete, there is no flow for the execution of the process, okay. Here non-preemptive, preemptive means there is no disturbance, okay. The processor will came to the new to ready to running to terminates, okay. That's all, okay. Whereas if it is preemptive means there is disturbance in the sense, just now we said na, running to ready is a preemptive, or running to waiting is a disturbance, okay. So here in these four circumstances, 1, 4, or we can say it is a non-preemptive, okay. 1, 4 are non-preemptive, whereas next to remaining are preemptive, okay. Next, coming to before going to discuss about the scheduling algorithms, let us see some few definitions about the scheduling algorithms. So here the concept is scheduling criteria. So there are various scheduling algorithms like FCFS, SJF, round robin, priority. So among the major four scheduling algorithms are there. Among the four, okay, we have to select the one best scheduling algorithm, okay. So in order to select the best scheduling algorithms, we should know some basic terminologies, okay. That is some CPU utilization, throughput, turnarounding time, waiting time, arrival time, like that, okay. In this scheduling criteria concept, we are going to see some basic definitions, okay. First one is CPU utilization, okay. What is meant by CPU utilization, okay? Just now we discussed right now, okay. The processor is always busy with executing some of the processes. Okay, then only we can say the CPU utilization was 100% satisfied. Okay, see, so the CPU is always busy with executing some of the processes means what will happen, we are going to use the CPU 100%. Okay, so we are going to utilize that CPU 100% only, then we can say it is a CPU utilization. That means how much we are going to utilize our CPU. Okay, how much we are going to utilize, we are going to execute the CPU always with some process. Okay, so this is the CPU utilization. We can say to make out the best use of CPU, not waste of any CPU cycles. Okay, we are not wasting the any waste of any CPU cycles means always we are giving some process to the CPU. Okay, we can say it is a CPU utilization. Next one is throughput. Okay, so what is meant by throughput? It is, we can say it is a total number of processes complete per unit time. Okay, per unit time, how many processes, okay, we are going to complete. Okay, we can call it as a throughput. Next one is turnaround time. So this is one of the major important definition. So for each and every algorithm, we are going to calculate the average waiting time, turnaround time. Okay, for that one we are going to know the what is turnaround time. Okay, so turnaround time is nothing but the amount of time to execute particular process. Okay, if there is a process, for execution of that particular process, how much amount of time it takes, that time we are going to take as a turnaround time. Okay, so next one is waiting time. See here, what is meant by waiting time? Simply the name itself. Okay, if there is one process, okay, one process came into the ready state. Okay, after that, when it will go to the ready running state, okay, when it reaches the, before going to the running state, how much time it will wait in the ready queue. Okay, then that time we can call it as a waiting time. Okay, generally from ready to running. Okay, before going to the running state, how much time it will wait in the ready queue, that is the time we can call it as a waiting time. Okay, we can say the sum of periods spent waiting in the ready queue, amount of time a process has been waiting in the ready queue. Okay, here waiting in the sense how much time a process should wait in ready state in order to execute by the processor. Okay, that is nothing but waiting time. Next one is response time. It is the amount of time in which the request was submitted until the first response is produced. Okay, response time means for example, there is one process executed until the amount of time in which the request was submitted until the first response is produced. Okay, the time which was taken for the until the first response is produced, that time you can call it as a response time. Next one is burst time or execution time. Okay, so it is a time required by the process to complete execution. Okay, it is also called as running time. Okay, burst time, or we can say it as a execution time. Okay, next one is arrival time. Arrival time means when a process entered into the ready state. Okay, that time we can call it as arrival time. Finish time is when the process is complete, its execution and exit from the terminated state, that time you can call it as a finish state time. Okay, so these are all the few definitions comes under scheduling criteria. Okay, let us talk about the scheduling algorithms. Generally there are only 4 basic scheduling algorithms are there. Okay, so first one is FCFS, SJF, priority, round robin. Okay, and next two are multi-level queue and multi-level feedback. Okay, whereas scheduling algorithms is concerned, there are majorly 4 only. Okay, first one is FCFS, SJF, priority, round robin. Okay, here first of all, based on these 4 algorithms, to decide which process, why we are going to use this 4 means to decide which process to execute first and which process to execute last. Okay, there are so many processes are in running state, ready state. Okay, so based on this, what this algorithms is saying, so which process, there are for example 4 processes are ready queue. Okay, among these 4 processes, which process P1, P2, P3, P4, which process is executed first, which one is executed last. Okay, so based on the algorithm, okay, there is for example FCFS is one criteria, SJF is one criteria, priority is one criteria, round robin is one criteria. Okay, so in order to decide which process execute first and which process execute last to achieve maximum CPU utilization. Okay, so generally we have these are the following scheduling algorithms. Okay, so let us see what is first come first serve. Okay, the name itself we have first come first serve scheduling. Simply we can say the process which come first into the ready queue, that process is going to be running state. Okay, the process which came from new state to the ready state, those process only should go to the running state. That is nothing but first come first serve scheduling. Okay, in the first come first serve scheduling, the process which came first in the ready state, that process only is executed by the processor, that is in running state. Okay, simply we can say it is we can compare this first come first serve as FIFO in queues. Okay, in queues also we have head and tail. Okay, head and tail. Head means front, tail means back, we can say back. Okay, here this FCFS uses the batch system. Okay, as you know what is a batch system. Okay, sequence execution of a processes. Okay, which in order first come first serve. Okay, and the next one more thing is the real time example of the first come first serve is we can say buying a tickets at a ticket counter. Okay, why? Because in ticket counter also the person who will stand in front of the counter, that person only will take the ticket. Okay, like that only we can compare this one as a buying tickets at the ticket counter. Okay, next to if you take the FCFS, if you take any algorithm, okay, the major thing is we are going to calculate the average waiting time. Okay, we are going to calculate the average waiting time. Okay, so what is meant by average waiting time? Average waiting time is the average of all waiting times of the processes. Okay, that means there is 4 processes. Okay, process P1 how much time wait, process P2 how much time it will wait, process P3, like that. Okay, we are going to calculate the waiting time. Average means by total number of processes. Okay, here what will happen is, one more thing is, here whenever there is low average waiting time means, then we can say it is a better scheduling algorithm. Okay, if we take FCFS, okay, if it has low average waiting time, then automatically we can say FCFS is the better scheduling algorithm. Okay, so in order to calculate average waiting time, okay, in FCFS we are going to take 4 processes, that is P1, P2, P3, P4. Okay, arrival time is 0. Okay, it will arrive, these 4 processes arrive into the ready state at time 0, and the burst time is we have given burst time 21, 23, 20, and 6 and 2. Okay, here the order is P1, P2, P3, P4 only. The processes from ready state to the from new to ready. Okay, the process P1 is came into the ready state, and then P2, then P3, then P4. Okay, there are 4 processes in ready state. Okay, what this FCFS is saying, the processes which come first, okay, is executed first only. That means here what will happen, first process P1 is executed, P2 is executed, then P3, then P4. Why? Because P1 is came into the ready queue at first, then P2, then P3, then P4, like that. Okay, so process P1 burst time is 21 seconds, milliseconds, we can say milliseconds. P2 is 3, P3 is 6, P4 is 2. Okay, here we are going to calculate the average waiting time. Okay, here average waiting time means waiting time of each process by total number of processes. Okay, here if you see how we are going to calculate the waiting time is, here process P1, okay, process P1 immediately it will start the execution. Okay, okay, here from 0 to 21, 0 to 21 means for process P1 how much time it will take for execution? 21. Okay, how much time is 21? Okay, that means process P1 should not wait. Okay, it will start at 0 and it will complete its execution at 21 seconds, that is 0 to 21. Okay, then after P1 which process is executed? P2. Okay, for P2 how much burst time is? 3. Okay, 3 means 21 plus 3, that is 24. Here P2, what this P2 is saying, P2 is starts execution at 21 milliseconds, it ends its execution at 24 seconds. Okay, that means how much time this process P2 is waiting? 21 milliseconds. See, this is clear, you should know clearly, very clearly. Okay, the process P1 is waiting time, P1 waiting time is 0. Here process should not wait, immediately it will came and go. Okay, P2 waiting time is, this is the starting time, this is the waiting time. Okay, P2 starting is 21, ending is 24. Okay, that means P2 waiting time is 21. Again P3, next P3 process is 6. Okay, 24 plus 6 means 30. Okay, again P4 means 30. 30 plus how much time, burst time? 2, that is 32. Here P2 is starts as 21 milliseconds, ends at 24 milliseconds. P3 will start its execution at 24 milliseconds and ends with 30 seconds. P4 will start its execution 30 seconds and ends with 32 milliseconds. Here what will happen? P2 waiting time is 21. P3 waiting time is 24. P4 waiting time is 30. Why? Because at 30 milliseconds only P4 will start its execution. At 24 milliseconds only P3 starts its execution. At 21 milliseconds only it starts its execution. Okay, that means how we are going to calculate means for process P1 the waiting time is 0. Okay, 0 plus P2. For process P2, how much time it will wait? It will start at 21 means it will wait at 21 milliseconds. Okay, up to 21 milliseconds. So 21 plus regarding P3. P3 starts at 24. It means it will wait. Waiting time is 24. Okay, 24 plus again P4. P4 means how much time it will wait? 30 milliseconds. Okay, 30, that is 0 plus 21 plus 24 plus 30. Okay, by how many processes are there? 4 processes. Okay, so by 4 means 18.75 milliseconds. Okay, here the total average waiting time, so average waiting time is, we can say, 18.75. okay, in this FCFS algorithm. Okay, so just now we have studied now for the above given process P1, P1 waiting time is 0. P1 is requires 21 milliseconds for completion. Okay, just now we have said now P1 requires 21 milliseconds. Again P2 requires 24 milliseconds for its completion. P3 30, P4 32. Okay, here you should remember one thing. Here P1 will start its execution 0. That means there is no waiting time. It ends with 21. P2 starts with 21. Ends with 24. Okay, ends with 24 means for P2 how much time is taken? 3. So for that one, 21 plus 3, 24. Here P2 starts with 24 means it will wait until 21 milliseconds. Okay, that's why 21. Again P3 24 starting time now. So for 24 means plus 24. So P3 waiting time is 24, like that. Okay, like that we are going to calculate waiting time in FCFS. Okay, next one is shortest job first scheduling. Okay, so here in the shortest job first scheduling works on the process with shortest burst time. Okay, in this FCFS we are going to take the process in the order which comes first into the ready queue, but in this one we are going to take the process with shortest burst time. Okay, the process which have less burst time, that process is executed first. Okay, so this is the idea here. Okay, here the best approach the best approach to minimize the waiting time. This is one of the best one. Okay, and next one is here also we have in SJF we have 2 ways, that is preemptive, we can say preemptive and non-preemptive. 2 ways we are going to implement the shortest job first. Okay, here in the shortest job first means, here shortest means the process which have shortest burst time, less burst time. There are 4 processes are there, P1, P2, P3, P4. Among those 4, which one is the less burst time? That process is executed first. Okay, so this is the concept. Okay, here what will happen? There are same FCFS concept only. Process P1, P2, P3, P4. Okay, burst times are 21, 3, 6 and 2. Here what will happen? First, what is the least burst time among the 4 processes? 2. Okay, so first P4 process is executed. Okay, that means P4 for P4 it requires 2 milliseconds. Then next one is P2. Next list is P2. Okay, that means P2. Okay, the time is 3. That is 2 plus 3, 5. Next one is next 2 over 3 over. Next one is next to less burst time is 6. Okay, P3. That means P3. So 5 plus 6, 11. So next one is finally P1. 11 plus 21 is 32. Okay, simple. Okay, here this concept is based on the least burst time. Least burst time is, first one is 2, that is P4, then 3, that is P2, then 6, that is P3, next 21, that is P1. Okay, here P4 starts its execution at 0. For P4 there is no waiting time, but P2 waiting time is 2. P2 will start its execution at 2, ends it 5 milliseconds. P3 waiting time is 5. P1 waiting time is 11. Okay, completion time is 32. How we are going to calculate the average waiting time? So 0 for P4 there is no waiting, 0 plus P2 waiting time is 2 plus P3 waiting time is 5 plus P1 waiting time is 11 by 4, that is 4.5 milliseconds. Okay, this is the average waiting time by using the SJF. Okay, so this is the shortest job first. Okay, the only difference between FCFS and SJF is, whereas FCFS is only that will concentrate on the first come first serve, the process which come first into the ready queue, that process is executed, whereas in the SJF we are going to concentrate on the shortest burst time. Okay, so this is the shortest job first. Okay, so this is regarding algorithms. Okay, FCFS and SJF. Okay, so